Welcome back. We're now on pressure and thinking about, we talked about temperature scales, having a relative temperature and an absolute scale and a relative scale. On pressure, this is going to be so important to determine the difference between a relative scale and an absolute scale. So when we're talking about pressure, we got to realize that we're sitting here on planet Earth, and we've got this continent sitting here that we call North America, and don't hold this against me. I don't know, Mexico and little Texas and Florida and coming up the East Coast, and then this is going down towards South America. Right, so this is our planet sitting right here, the planet Earth. And we know, two E's, not two E's in Earth, and we know this, that when we look up, there is an atmosphere that surrounds the planet. And I get out here, I'm in space, and they call it the vacuum of space. The reason they call it the vacuum of space is our atmosphere is pushing down on us. And if I was to measure that atmosphere, it's equal to 14.7 psi. So even when I depressurize a piping system, it still has all of this pressure in it. So what that's saying is 0 pounds gauge on my pressure of my pipe that's depressurized, and here's my pressure gauge reading 0 pounds gauge, and I've depressurized the pipe. Wait, it still has the pressure of this atmosphere in it. So it's relative. Gauge is a relative scale. It's relative to atmospheric pressure. So let's look at that on a cool little figure, absolute scale. So here's how I like to do it. This is 0 pounds gauge. And then the atmospheric pressure we said was this thing right here. The Earth is just coming right here. This, if I was to remove all of the atmospheric pressure, I would get down to 0 pounds absolute, which is the vacuum of space. We said this distance right here is 14.7. That's the distance from these 2 points, because that's the pressure that's being exerted by atmosphere. Well, if I am reading a gauge monitor and I start withdrawing the air out of a pipe, I'm establishing something less than atmospheric conditions. That's a vacuum. So that if I removed all of the air, we would call this 14.7 psi V, because the V denotes a starting point of gauge pressure or atmospheric pressure of 0 and establishing a vacuum. That is no different than saying here. When I come up and started here and I went this way, that is 14.7, get rid of this 14.7, psi A, because the A denotes my starting point. I started at absolute 0 pressure and I pressurized it to 14.7 psia. 14.7 psia is equivalent to 0 pounds gauge. So to convert to an absolute pressure, you take the pressure that you have plus P atmosphere. So 0 pounds gauge plus 14.7 would give me an absolute pressure of 14.7. The weird part about it is we can actually express what atmospheric pressure is being felt in several different units. We could say that I know it's 14.7 pounds, but atmospheric pressure would also, if I was to look at the distance between the two, it would push a column of water up 33.9 feet of water. Such that if I started establishing a vacuum, that would be 33.9 feet of water vacuum. Or if I started here with my water and went to gauge pressure of 0, that's 33.9 feet absolute. This is key. If I put a pump right here and I started to lift the water at atmospheric temperature and pressure, when I lift water 33.9 feet, I've established a perfect vacuum. And I can't lift the water up any higher than 33.9 feet. I would have to take the discharge and either create a jet pump arrangement or push the water up or lower the pump down here. So the best pump in the world can only create a perfect vacuum. The best pump in the world can only lift water 33.9 feet. You've got to do something else. There's other ways to express this. We can, if feet of water, therefore we can do it in inches of water. It's pretty cool. So this is misunderstood all the time. Here's 0 pounds gauge. Here's 0 pounds absolute. The distance between the two is 14.7 psi. I didn't put a letter out here. I didn't put a letter at the end because if I started here and went down, boom, it would be 14.7 psiv. If I started here and went up, that would be 14.7 psia, denoting the starting point. If I wanted to express this in feet of water or inches of water, 0 pounds gauge, 0 pounds absolute. The distance is here to here. Atmospheric pressure would push a column of water 33.9 feet of water in the air. That distance is also about 408 inches of water. So when we run standby gas trains and we have to establish 0.25 inches of water vacuum in our reactor building, let's think about where that is. This entire distance is 408 inches of water vacuum when I started here. We have to establish 1/4 of an inch. That is just below atmospheric pressure. So sometimes you may ask yourself, if it's not that much of a vacuum, why do I have such a hard time opening the reactor building door? Aha! Even though the pressure is not that much, we've got a pretty big door. With a big door and a little bit change in pressure, it's going to require more force to open the door. Force equals pressure times area. It's not that we have a big pressure change, it's we have a big area on the reactor building door. So you can see all this, and it's super important. I can't express enough that you understand the difference between a gauge pressure and an absolute pressure. It can be expressed in mercury as well, mercury being very dense. If I was to establish a perfect vacuum in mercury, it would raise water, our vacuum, it would be able to lift mercury 29.92 inches. So 29.92 inches of mercury is a perfect vacuum. I could also express that in absolute scale. Starting at absolute, when I got to 29.92 inches mercury absolute, I would be at 0 pounds gauge. All right, so very important. When we're using these things here later on, these steam tables, it is imperative that you always, don't ever forget this, convert to absolute. That means when you're given a gauge pressure, add 14.7 and turn it into an absolute pressure. There's a knowledge requirement right there on that page. It says we had to know on the previous knowledge requirement, K102, we needed to know about temperature. Look here, the very first knowledge requirement, convert between absolute and relative pressure scales. You need to know this very, very, very well.